Hi, in this video I'm going to explain about ASA congruency. In fact, ASA congruency and AAS congruency, these two are one and same. Let's see how these two are same with an example. In this diagram, TUS and UVS, they are two triangles, but no additional information is given. No additional information is given. Now you can see that in this diagram, there are two triangles, but no additional information is provided. So I can take this one as given these arrowheads. These arrowheads indicates that line segment TU is parallel to SV. So I can say that these arrowheads are indicating that TU is parallel to SV. And anything else? Yeah, just to make it a little easier, I can say that angle 1 and angle 2 are marked. So these two angles are equal. Angle 1 and angle 2 are equal. Angle 1 equals to angle 2. To be more specific, if I name this one, it is angle 1 is TSU. You can see that it is TSU. So angle TSU equals to angle 2. Angle 2, you can take this way, starting from S. Make sure that the vertex is in the middle. So it is angle SUV or VUS. So angle 1 equal to 2, or you can write that TSU equals to SUV. Okay. Then here, any other additional information? That's it. So let me take my T chart, and let me write that my statement here, and why I am taking that statement to support my statement. I am giving you the reason also. So the first one is angle 1 equals to angle 2, or else I can say that angle TSU equals to angle SUV. How do you know this one? Because it's already given in the question, or it is marked in the diagram. So angle equals to angle. Next, several times I told you that when two triangles are given together, you see that something is common in both. Please notice that SU is a part of triangle TUS, and also it is a part of triangle SUV. So if there is a common side, we say that these two are equal. SU equals to SU, or SU equals to ES. Either way you can write it, and side. Okay. So how do you know this one means? By reflexive property. And if you want to prove ASA, then where is the other angle? Can I take angle T equals to angle V? It is not mentioned. It is not marked. How about this angle, which is angle TUS equals to angle USV? This is also not marked. But can I take that these two angles are equal? Once think of the properties of parallel lines. So we know that these two lines are parallel, which is TU is parallel to SV. If these two are parallel, think of parallel lines, the properties of parallel lines. Okay, I'm taking two parallel lines, and if you are given, let's say that if you are given a transversal, okay, then is there any relation is there any relation between this angle, and this angle? Think for a while. Yes, these two angles are equal and these two are facing the opposite direction, and they are on either side. They are on either side of the transversal. So these two angles are equal, and it is these two angles are equal. TUS angle TUS equals to angle USV. These two angles are equal because these two are on either side of transversal. We call them as alternate angles. Alternate angles are equal. They are actually interior alternate angles, to be more specific. Okay, so don't expect each and every information, every bit is given in the question. Sometimes some information may be missing, then you have to think like in the given question, TU is given as parallel to SV, then you have to think of the properties of parallel lines to get the idea. Okay. Again, let me take another question. In that we'll discuss how SAS and ASA, these two are to be same. Okay, in this example, you can see that the symbols are marked. So let me mark as numbers like 1, 2, 3, and 4. Okay, so I see that angle 1 and angle 2, these two are having the same kind of markings with the same symbols, like with one line. So angle 1 equals to angle 2. In a layman's language, I'm writing as angle 1 equals to 2. And when it comes to 3 and 4, the 3 is having double line, angle 4 is also having double line. So just I am writing as angle 3 equals to angle 4. Okay, so what is the name of angle 1 means? You can't say just A, because at point A there are two angles. There are two angles. So simply you cannot take a single letter. So let me take this one as angle 1 means, oops, let me use a different color. Let me use a different color. If I'm taking angle 1, then it is BAC. BAC. I can't take just angle 1 as A. When it comes to angle 2, this is going to be CAD. CAD. Okay. So again, I'm repeating. Angle 1 is BAC. Already just now I marked and it showed you. And when it comes to angle 2, it is angle CAD. Then angle 3 is, I can take a single letter because there is only one angle at point B. And angle 4 is, it's angle D. So I'm trying to prove these two triangles to be congruent. So let me write my statement this side and reason to support my statement. So angle 1 equals to 2, that is given. Instead of angle 1 equals to 2, I can write angle BAC equals to angle CAD. How do you know? Means these angles are marked in the diagram. So that's given. Next, coming to the second one is angle 3 equals to angle 4. That is also given in the diagram. So angle B, instead of angle 3 and 4, I am writing angle B equals to angle D. These angles are also marked. So it's given. So angle equals to angle, angle equals to angle. And you see that there is a side which is common to both the triangles, which is AC, right? So if there is a common side, so AC, line segment AC is a part of triangle ABC, and also it's a part of triangle ADC. So this is by reflexive property. Now, can you say that these two triangles are congruent by AAS? In the previous part, that is SAS congruency means the angle must be included. I repeat, if you are taking SAS congruency, then the angle must be included. Included means it must be in between the given two sides. It must be in between the given two sides. Then how about ASA? How about ASA? Is the side, is it necessary to be exactly in between the given two angles? The answer is, I would say, no. Because if two angles are equal, then the third angle will be equal to the third angle of the other triangle. How come? You know that sum of three angles of a triangle is 180 degrees, right? Therefore, sum of three angles of a triangle is 180 degrees means, example, well, let me take an example. Let's say two triangles, two triangles, two triangles are given, say ABC, DEF. Okay, now let's take BC equals to EF. Just I'm marking these two sides are equal. And I'm taking that angle B is 50 degrees and angle A is 70 degrees. And here angle E is 50 degrees and angle D is 70 degrees. Are they congruent means? Friends, please notice that the side is not in between the given two angles. So I see that two angles and one side are equal, two angles and one side are equal. So can I consider ASA postulate or not? Because ASA means the side, is it necessary to be in between the given two angles? If so, the side is not in between the given given two angles. You can notice that, right? But still these two are congruent. How? Because I know sum of three angles of a triangle is equals to 180. Let's say what is the third angle, which is angle C. Can you figure it out or not? Think of it. Yes. Sum of three angles equals to 180 means here I got 120 degrees. I got 120 degrees. 120 plus what angle, what value that makes 180 means you can guess, or else you can use a simple algebra that 120 plus x equals to 180. Then take away 120. Then the value of x equals to 60 degrees, right? Therefore, my third angle is 60. Therefore, this angle is 60 degrees. In the same way, in the other triangle also, you know, two angles, what is the third angle means? This is also 60 degrees. Now, even if you ignore 70 degrees, still it is obeying ASA. Now the side is included, right? Therefore, in ASA congruency, even the side is not included, which means the side is not in between the given two angles, still it is acceptable to say that ASA. If you are not comfortable using ASA, then you can say that AAS. So the side is not necessary to be included. Okay?